Hi everyone, welcome to this episode of Keipert Labs. In this video today we're going to be talking about the concepts of distance versus displacement. Okay, so two words that are similar for physicists but they mean specific different things. Okay, so I want you to imagine something for a moment. Okay, so let's say that we've got a person. Clearly I'm meant to be a science teacher, not an art teacher, but you know, work with me here. Okay, so we've got a person. And so they're walking, okay? And so let's say that that person is walking this way. Okay, so just like we talked about in a previous video, that we can talk about this person's speed, we can identify their direction, and so therefore then that gives us their velocity. We can express, so maybe they're doing walking at plus 4 meters per second. If we describe going this way as being plus and going this way as being minus. Okay, so now what we want to do, so let's say that they walk, and then they walk all the way to the end. Excuse the smudge, I will clean it off. Okay, they walk all the way to the end up there. Okay, and so then they're up here, and now they're going to walk back. Okay, so we've got our person up this end, and now they're going to walk back over this way. Okay, so maybe during the second part of it, if they're walking at the same speed, we could say that they're walking at minus 4 meters per second. We're describing the direction as being the opposite way. But now, there's two kind of questions here. The first is, how far has that guy gone? Let's say that from here to here is 5 meters. Okay, so he's travelled 10 meters of distance. Okay, because he travelled 5 meters over here, and then he's turned around and travelled 5 meters back again. However, what I want you to ask you is, how far is he from his starting point? Okay, and so the answer, so he's walked all the way this way, then he's walked all the way back. So he has walked 0 meters from the starting point. Now, at this point you're probably thinking, well, who cares, Mr. Keipert? It doesn't bother me in the slightest, okay? But for physicists, we want to be able to think about objects, not just in terms of, right, well, what's the total amount that they've travelled, but also where are they relative to where they started with? Because, some objects have kind of repeating motion patterns. You can imagine, like a wave on a string that you might have looked at last year. And this idea that we can see that, that waves kind of go up and down. And so for us as physicists, that often it's very useful for us to think about where the object is relative to its starting point. And so what we do is, so we can say, all right, well, this guy's travelled 10 meters of distance, but he's back at his starting point. And the distance from where he is to the starting point is called his displacement. Okay, so that is our object's distance. All right, I'll rewrite it. Okay, so an object's displacement is the object's distance in a straight line from its starting point. Now, when we looked at our earlier example, that when so we started with the man who was here and then he walked all the way to the end. If he stopped at the end and stayed there, at that point, his distance and his displacement would be the same. I'm just going to put a nice little box around this because it's an important kind of definition to remember. So he would have been 5 meters, he travelled 5 meters, and he was 5 meters from his starting point. However, because of the fact that he then went back again, he travelled another 5 meters, but landed back at his starting point, so his displacement was 0. They were a straight line distance from where he is to where its starting point was, where his starting point was 0. Okay, and so this sort of thing is particularly important if we're thinking about, objects that are moving in, like in 2 dimensions, as far as maybe, an object is kind of moving forward and then across and then back down and then across again. The opposite direction, that being able to actually kind of keep track of how far it is away from that starting position gives us useful information to describe their motion. Okay, thanks very much for watching. Bye for now.